So hello everyone, I'm Raghvendra Singh. Welcomes you all in the another video. So in this video we are going to discuss unit number 2 of discrete mathematics. Okay, so there are some topics related to relational which you have studied in I think in 12th class. What are the domains, functions, and reflexive, symmetric, transitive? These are relations. What is equivalence and all. So basically, in this video, we are going to discuss some topics that are binary relations, equivalence relations, hasse diagram, lattice, pigeonhole principle, algebraic structure, isomorphism. Okay, so let's start with binary relation. You all know what is binary relation. Binary means two. Okay, so how two elements how two elements connected how two elements connected, is it greater than or sibling, is it greater than or sibling? Okay, is it greater than or sibling? Now comes in relation. So basically relation means R is the relation from A to B, and from A to B, set of ordered pair where first element comes from set of ordered pairs. Okay, set of ordered pairs where first element comes from A, where first element comes from A, and second from B. It's very simple. Suppose A cross B, there is two tables where is 1 comma x, 1 comma y, 2 comma x, 2 comma y. So here domain is 1 comma 2. So property is mod of A is equal to n, A cross A, n into n square. Okay, now some set operations. Set operation. So basically set operation is first A union B, second A intersection B, third A complement, means C means complements, and I'll discuss what is C. So you all know what is union. Union means if there will be given two elements A and B, then we will combine both element and write in a one table this. Intersection means the common will be taken from these two tables. Okay. So for example, A is equal to 1 comma 2 comma 3 comma 4. B is equal to 2 3 1 7. So here A union B, I'm not going to write at all, it is too lengthy. Both everything I will write here, like here to here, like here 1 2 7. I will write this. And now what A intersection B? B means common. What is common here? 1 2 3 4. So here 2 and 3 is common. 1 is also. So 1 comma 2 comma 3 is common. So I'll take this. Okay. So now Venn diagram, you know already, like what is Venn diagram? A rectangle, then inside of this what will be common, we will do that. You all know that. So now we are going to do logical equivalence. Logical equivalence. So what is logical equivalence? So logical equivalence is if all have same truth values, same truth values, are denoted by P equivalence Q. P and Q were two proposition. Okay. Now let's discuss about set. So basically set, it is well-defined class or object. It is well-defined. Class. It's well-defined class or collection of objects. Okay, so well-defined class, collection of objects. So there are some types of sets. Types of sets are universal set. First is universal sets. Second is equality of sets. And third is singleton set. And fourth is disjoint set. And fifth is all possible set of elements. all possible set of element okay. Now the another is power set. So px all possible set element a is equal to 1 comma 2 p of a 5 comma 1 comma 2 comma 1 comma 2. So p of a is 4. Now there is some idempotent law. So commutative property. First is commutative property, then associative, then distributive. Commutative, associative, distributive. So these are some properties in idempotent law. Now what is De Morgan law? Basically De Morgan is nothing but A union B complement A complement intersection B complement intersection B complement means A complement union B complement. Okay. So this for very basic. Now hasse diagram. It's very simple to understand hasse diagram. Hasse diagram. A simplified map or drawing a partial order who is so a geographical representation of the partial order. A geographical representation of the partial order relation. Representation of the partial order relation in which all arrowhead order in which all arrowhead are understood to be pointing upward. Are understood to be pointing upward is known as the hasse diagram. Is known as the hasse diagram. For example, a is equal to 1 comma 2 comma 3 comma 4 comma 5. So by a relation, so basically 1, 2, 3, 4, 5. So this is something like this. One more thing, that we do not need to show which number is dividing itself. Okay, so now let's discuss. Okay, so here I have written do not need to show which number is dividing itself. So here like 1, 2, 3, 4, 5. Instead of this, I can write 1, 2, 3, 4, 6, 8, 6, 8. So how many pair can be formed? So basically, one can be with 2, one can be 3, one can be with 4. So I can write first of all, one can be with 1, one can be with 2, 1, 3, 1 with 4, 1 with 5, 1 with 6, and 1 with 8. And same here, 2 with 2 with 2, 2 with 4, 2 with 6, and 2 with 8. Now same for 3. 3 can be with 3, 3 can be with 4, 3 can be with 5, 6, 3 can be with 8. 4 can be with 4, 4 can be with 6, 4 can be with 8, and 6 can be with 8, and 6 can be with 6 also, and 8 can be with 8 only. So here as we can see that these are some numbers which are dividing itself. So I just need to show basically I just need to show 1 with 2, 6 with 2, 4 with 2, 4 with 8. Okay, now just pigeonhole principle. So pigeonhole principle. So it is just nothing. It is just like if we have 6 houses for pigeons and we have 7 pigeons. So there is a strong possibility that in one house 2 pigeons will be there. It is very simple. Okay. So if 6 pigeon has 5 hole, if 6 pigeon have 5 hole, if 6 pigeon have 5 hole, then minimum then minimum in one hole there will be two pigeon. In one hole there will be two pigeon. Okay, so kn plus 1 is equal to 0. This is the formula. So now isomorphism. When two different looking sets or structure actually work exactly the same way. Okay, when two different looking sets or structure exactly work in the same way. Two different looking sets or structure actually work exactly in same way. Actually work exactly in same way. Okay, so these are some types. There are some types: number of vertex, number of edges. So like number of vertex, number of edges, number of connected disjoints, planar or non-planar. So basically homomorphism. Homomorphism. So homomorphism is a structure adding or removing a vertex. A structure adding or removing a vertex. Adding or removing a vertex. Okay, so this was unit number 2. So thanks for watching. Now we will see unit number 3, that is permutation combination, and 4 and 5. Okay, thank you for watching.